Find a power series representation for the general solution to 2y double prime plus xy prime plus y equals 0, where y of 0 equals 1 and y prime of 0 equals 4. List at least the first 5 non-zero terms of the series. We should center our power series at 0 since that is where we know the initial values of y and y prime. So y will equal the sum from n equals 0 to infinity, a sub n x to the n. Y prime is the sum from 1 to infinity of n a sub n x to the n minus 1. And y double prime is the sum from 2 to infinity of n minus 1 a sub n x to the n minus 2. Plugging these in, we get 2 times the sum from 2 to infinity, n minus 1 a sub n x to the n minus 2, plus x times the sum from n equals 1 to infinity of n a sub n x to the n minus 1, plus the sum from n equals 0 to infinity of a sub n x to the n equals 0. We can move the factors of 2 and x into their respective series, which makes the exponent on x in the second series n. Then we can use index shifting on the first series to change the exponent from n minus 2 to n by adding 2 to every n inside the series and subtracting 2 from the starting n. Now, to make all the series start at the same n value, we should first check to see if we can change the starting value of the middle series to n equals 0 without adding any non-zero terms. We're in luck. When n equals 0, we get 0 a sub 0 x to the 0, which is just 0. So we can safely rewrite the series as starting at 0 instead of 1. Now we can combine all three series together. Comparing coefficients, the sum from n equals 0 of 2n plus 2 times n plus 1 times a sub n plus 2 plus n a sub n plus a sub n x to the n equals 0, which is equal to the sum from 0 to infinity of 0 x to the n. So the whole expression in brackets has to be equal to 0 for all n. In other words, 2n plus 2 n plus 1 a sub n plus 2 plus n plus 1 a sub n equals 0 for all n greater than or equal to 0. We can solve this for a sub n plus 2 and say that a sub n plus 2 is negative n plus 1 over 2n plus 2 n plus 1 a sub n when n is greater than or equal to 0, which simplifies to a sub n plus 2 is negative 1 over 2 times n plus 2 a sub n when n is greater than or equal to 0. And if we want, we can index shift the recursive formula, subtract 2 from all of the n's in the formula and add 2 to the starting n to say that a sub n is negative 1 over 2n a sub n minus 2 whenever n is greater than or equal to 2. Notice that the recursive formula is only valid for n greater than or equal to 2. This is because since we're solving a second order equation, both a0 and a1 are arbitrary constants. Except this is an initial value problem, and therefore a0 equals y of 0 equals 1, and a1 equals y prime of 0 equals 4. Now we can use the recursive formula to find more coefficients, stopping when we found at least 3 more non-zero coefficients. So we know when n equals 0, a0 is 1. When n equals 1, a1 is 4. And when n equals 2, a2 is negative 1 over 2 times 2, a sub 2 minus 2, which is negative 1/4 a0. which is negative 1/4. For n equals 3, a sub 3 is negative 1 over 2 times 3, a sub 3 minus 2, so negative 1/6 a1, so negative 2/3. And n equals 4, a4 is negative 1 over 2 times 4, a sub 4 minus 2, which equals negative 1/8 a2, so positive 1/32. Now that we have 5 non-zero coefficients, we can stop and write that y is 1 plus 4x minus 1/4 x squared minus 2/3 x cubed plus 1/32 x to the 4th, and then it keeps going.